Hello everybody and welcome back to our physics engine. So today I'm going to make a short video and I'm just going to make some corrections to code that I got wrong. And I want to give a thanks to everybody who's been participating and watching. Thank you for your views and thank you to everybody who's been commenting. It's been a learning process and it's going to continue to be a learning process for me. And I hope that it's not just me learning stuff as well. I hope that everybody is able to learn some new things as we go through this process of making a physics engine. And thank you to everybody who's been commenting and showing me some spots where the code is either wrong or the math is wrong as well. So thank you very much for that. So the first thing I need to correct is the separating axis theorem. And I think it was 2 or 3 videos ago we talked about how to find the normal and depth value of our collision, of our intersection, using the separating axis theorem. I want to say thank you to Alex Krieg, I hope I'm saying that right, who commented and showed me the reason that we need to make this correction. Here's our intersect circle polygon function, and we can start with this one, but we're going to correct this function as well as the intersect polygons function. In the previous videos, I talked about how we can get the correct depth and normal value after we exit the loop where we are projecting our vertices. So here in this loop, we're projecting all the vertices onto this axis. And the problem we run into with the way I wrote it is we're not normalizing the axis. And so the projections that we're getting with these two functions here are not going to be in the same scale from one loop to the next. So in the first loop, we're going to get projections in a certain scale. And in the next loop, the projections will be on a different scale. And so they're not really comparable. But if we normalize the axis, then from one loop to the next, the projections are all going to be on the same scale and we can compare them correctly. So the correction I need to make is that inside this loop, we actually need to normalize the axis every time that we want to project onto it. So I'm just going to use the flat math library. Let's go ahead and normalize this axis, and that is all we need to do to that function. Okay, so all we're doing is we find the axis and then we normalize the axis and then we can project onto the axis. Okay, and that needs to happen. If we want to get the correct depth values, we need to do that every time. There's that one. We also need to scroll down here. Here's the next axis. This is the axis we're finding the axis between the closest point on the polygon and the circle center. Again, we're going to project the vertices onto this axis, and so we need to normalize the axis first. Okay, and now since we're normalizing here and inside the loop here, every time we record the normal as the axis, we don't need to make any corrections at the end. So right here, we made corrections to our depth and normal value to get them in normalized space. But we're already doing that, so we can go ahead and get rid of this code right here. So we don't need to find the depth value and normal are actually already correct, so we don't need to do this anymore. And so that's it for the, this is the intersect circle polygon. And so we need to do the same thing for the intersect polygons function. So here we are in the intersect polygons, and here we go, we find the axis, and every time we find the axis, before we project onto that axis, we need to normalize it. Okay, and then same thing for the second loop. We're just going to normalize this axis. Okay, and then again, since the axis is already in normalized space, we don't need to do this code anymore where we make corrections for the depth and normal. And so we get rid of that, and then everything right there looks good. So now our intersect polygon and intersect polygon circle function will return the correct normal and depth value. And I think one of the reasons I didn't really see in previous videos the need to do that, I think the shapes I was using were actually very symmetrical, meaning like the squares I was using, all the sides were the same. And so I didn't really see a problem because all the values I was passing in here were all the same length anyways. When you start running into different lengths for polygons, at least for the sides or the edges, I think we'd probably start seeing a lot of problems with this algorithm. All right, that should be it for correcting our separating axis theorem and our intersect polygon and intersect polygon circle functions. Now, the other thing is with our physics math. And I want to thank MegaRev for showing me the correction on this one. In our FlatBody, here is our step function. And last time what we did was we incremented the velocity by a force over time. And actually what we want to do is increment the velocity by an acceleration. And he pointed out that force is equal to mass times acceleration. When we're incrementing the velocity here, we want to increment it by an acceleration. We don't want to increment it by a force. And so we use this formula to find the acceleration, and we end up with the acceleration is equal to the force divided by the mass. And so in order for this equation to be correct, we want to actually increment the linear velocity by the acceleration. And so I'm just going to find the acceleration due to the force. And that's just going to be the force that we have divided by the mass of this body. Okay, and so now we have the acceleration. So let's go ahead and provide the acceleration to this equation right here. Okay, so this should be the correct function now. All right, so we calculate the acceleration, which is force divided by the mass, and then we increment the velocity by the acceleration on a per time basis. So there's the corrections I needed to make. Let's go ahead and run that and just see what it looks like. Okay, there we go. And it's a little bit more sluggish, and it feels like I need to put more force if I want to move the body. So I'm going to actually increment the force. So here is our game class and our update. Here's the force magnitude that I was using, 8. I'm going to go ahead and let's go ahead and triple this. I'm going to make it 24. Okay, there we go. And everything looks good. Looks like it's working. And the collision detection is now going to be correct, completely correct, regardless of which type of polygon we're using. And the acceleration and force equations should be correct as well. And remember, force is in newtons. And so I'm basically applying 24 newtons here. I'm going to double that again because I want to be able to move the body pretty quickly. Yeah, that feels good. So we're applying 48 newtons, and then calculating the acceleration from the force, and then incrementing the velocity by that acceleration. Again, thanks to everybody who helped me make those corrections. And as we go along, I'm expecting to make more mistakes. So if you see anything that could use some correcting, let me know. Again, this is a learning process, and I want to thank everybody who's helping me on this journey. And I hope that everybody who's watching, that you're learning something as well. I'd like this to be something that we can all learn together.